Looking for a clear way to watch and manage your critical environment facility? Introducing Vision by Phoenix Controls. Vision is a real-time critical systems analysis tool that allows you to customize reporting, scheduling, and alarm management. This comprehensive tool supplements your facility's existing building automation system and provides full web-based operation. With Vision by Phoenix Controls, you will enjoy features such as a full suite of powerful and customizable real-time reporting tools, critical analytics at every level to help evaluate and maintain proper building operation for facilities, safety, and energy management. Easy to read and navigate UI, providing detailed data on air change rates in real or historic timeframes. The ability to customize the visuals to represent specific campus, building, floor, and room specifications. A drag-and-drop architecture builder, plus many pre-built mechanical templates, makes for easy setup and updates as your facility needs grow. Custom reporting to help provide certification management, trend analysis, and energy efficiency tracking information, and more. Review, report, and make equipment decisions with airflow building diversity visibility. Information feeding into Vision is not limited to Phoenix Controls equipment. For your critical room control system needs, Phoenix Controls is simply the best in the business. You may already know the quality and reliability of our Venturi valve system. Well, now the innovative Vision analysis tool is just one more reason to look to Phoenix Controls. Connect with your Phoenix Controls representative for a demonstration and see how you can improve visibility into your critical environment facility with Vision by Phoenix Controls.
Okay, today we're going to spend a few minutes, brief time going over and explaining some applications on the new Vision analytics software tool that was developed as a supplement to the existing building automation system. You'll see a lot of the same capabilities with additional tool sets and reporting designed specifically to help the individual end users and or facilities maintain and manage these critical spaces. It's all built around a web-based application, which allows you to call this up really from just about any type of web type of software. Google Chrome, if you're using your phone, you could use Safari or whatever the app is that you use with the Droid. Tablets, it really doesn't matter. The system is intelligent enough to know what's trying to connect to it, and then it in turn will switch its navigation capabilities to allow you to have the same interface, just using different devices to do it. So we'll get started. This is just using Google Chrome, as you see up here. We'll just log in, and today we're going to focus on the healthcare application and applications that you might see with Vision in those critical spaces. So on the initial load, we're showing kind of just a general type of campus that you might see in regards to what you might find either in a university and or a hospital district. It really is the same either way. But you may find that you're dealing with a healthcare facility that has satellite branches, and we'll show you a quick example what that might look like. You might come at it from an approach of using something like Google Maps. I mean, with the Internet of Everything today, most of these facilities are interconnected through VPN access. As if when you're at one facility, you can see the other one as if you were there, and it utilizes and kind of piggybacks on that same technology. So in that case, it really doesn't matter what you do or how you lay it out. The point is that there's a lot of capabilities in what a facility might use and leverage for their benefit. So in this case, we're going to focus as if this was a hospital. We'll jump into that area. And then we've got multiple applications we'll try and briefly touch on as we go through it. We'll start up here at the top, which is a pandemic floor. There's been a lot of discussion on pandemic modes, especially with COVID. And as we see even down the road in regards to what are ways that we can, not only manage our hospital but our bed allocation so that we don't run into the problems that we foresaw with COVID, which is going to be, we need more of the ICUs. We need more of the pressurized zone. So in conjunction with a Phoenix system, it's very easy to manage typical patient rooms, and then easily converting them over to what might be considered an isolation and or pandemic application. We'll show you here as an example where we have, let's say, 3 of your typical patient rooms all running under the normal mode. Again, with Phoenix valves in the ductwork to provide your means of pressurization, there's no sensors that need to be recalibrated. There's no clogging, no cleaning. So these systems can operate as a normal mode, essentially years with no interface or additional maintenance that would be required. And you'd have a very confident system installed, knowing that when you got to the time where you might need additional rooms for pandemic cases, that you'd have wings and or floors available to easily and essentially immediately turn over. And we'll show you a quick example of that. So in addition to these modes, which we'll get into, you have all of the patient information shown here. Now, what's interesting is you'll show that right now we're running these rooms with an air change rate set point of 4, as you see, because they're all the same temperature set points of 72. Now, obviously, if we're running in any kind of other mode that requires high levels of isolation, we don't have the time to train nurses or train people or facilities people that haven't looked at this in 5 years how to do it. So the idea is just very simply, I'm going to change these all into a isolated mode. And I'm going to do that essentially with just a click of the button and saying we're going to make these quarantines. And then I'm going to change mode 1, so that's a quarantine. Now, and I'm going to point out, just as we're going through this, that immediately patient room 1 went not only negative, but the set point changed to 70 degrees. It could be whatever you want it to be. The differential pressure set point was to be a negative 0.1, and the air change rate is now at 12, as opposed to these, which you see down here, which haven't been changed yet, where we're at a 0.05, 72, and 4. So you'll see these independently changing and immediately changing to, again, make it a very simple mode where all the person has to do is, I want to change this from one mode to the next. And you'll see that the ability not only to change the rooms, but also the associated air handling unit to change this into a completely pandemic floor in a matter of seconds. All right, so all my rooms are now running negative. As you can tell, very high air change rates, ready to roll. But now we're going to go check on our air handling unit and see what's happening there. And so here we have a pandemic-ready air handling unit. As you can tell, we've got 15% outside air, relatively normal, and then just return air coming from these pandemic floors. With the switch of the button, we're going to actually increase our 100% outside air up to 100%, shut off the return, enable the exhaust fan. So now we have a fully pressurized suite. As now you have the dampers opening, the air handling units turned on, or the exhaust fan turned on, and your 100% outside air. So now you've got a completely pandemic-ready air handling unit, essentially by the switch of a button. We'll then jump back to the floor plan and see that everything is as it's supposed to be. Very simply and very easily, you can create within seconds a whole floor wing and with very little knowledge of the system other than just knowing what mode you want to go to. If we jump into this, we can get some additional information off of that particular mode, where we're not only tracking what's happening, we're seeing here that we were running in a regular mode, and then we see where we switched it into we were running in a quarantine mode. Then we at the beginning of the demo, we switched it back to a normal mode, and then immediately went back to a quarantine mode. And this would track all the various modes that room is in, which gives you some level of accountability in regards to nurses that are switching patients in or out. Because from the quarantine mode, you typically want to go to a dirty mode, then you go to a clean mode, and then you make the room ready for for occupancy at that point. In addition, we also have all of the trending associated with this room for temperature set points and/or are we maintaining the control, with the set points being yellow. Here we have the actual the humidity, and this looks a little busy, but essentially it's showing the pressure relationship where we went from a point -0.5, then we switched it into quarantine to a -0.1, and then we're keeping track of the various door openings and closings, because at that point you're really wanting to determine how often people are coming in and out of these spaces. Obviously, the less the better, because that keeps your barrier and it keeps the person quarantined who's in there. And then you obviously have your air change rate that shows where we were running at a 3 to a 4, and then immediately when we go into that particular mode. So all this is time stamped. All of this information can be sent out, and then this could actually be reported and used for accreditation that these spaces ultimately would require. And again, you would see the same thing on the other two rooms, as you could jump between those to see similar information, just guaranteeing the not only the adjustments were made, but also that the control tracked with those particular settings as we went from one standard room back. So let's say the quarantine is over. We're going to go back. I would, again, set these up to an unoccupied dirty because they haven't been cleaned yet. And this is the approach that you would take to make sure that we went from a dirty mode from a quarantine mode into a dirty mode, so that there would be a process and a procedure to make sure that, as you can tell right here, it's now these rooms are no patients because nobody has cleaned those rooms yet. We would go back over here to the system operation and adjust this into your normal mode, damper switch. We're now back to a standard air handling unit. As you would expect, once these rooms have been cleaned, we would then go back, set these up to now an unoccupied clean. And then we'll just do that real quick before we go on to our next application. And we'll do the last one here, unoccupied clean. So now you have all three rooms ready for occupancy, either as a normal patient and or positive, negative, whatever relationship you want, with the individual notation shown of the rooms that are being switched, where they went from a dirty, then they went to to the clean, and that's where they're at right now. So anyway, there's your indication in regards to how and the pandemic modes could be controlled and or easily set up using the Phoenix Vision analytical software tied with the Phoenix Air Valves to create just about any type of mode very easily and in a secured method. The next group that we'll look at, moving down, is the operating room. Again, the idea would be we create a very simple approach for the nurses to know that there's a parameter within the operating room, and these suites are typically built out in multiple arrangements from 4 to 6 to 8, but that the end user and or the nurse on staff would be looking at these rooms, and if there's a problem, they could either just stop here, call facilities and say there's a parameter that we have a problem with, or they could jump into the room itself to get a range of information associated with the room's operation. In this case, we're looking at temperature, humidity, air changes, pressure, total VOCs, and particles, all shown here at the top. And then a breakdown, not only of the history of those points, but also an indication of the set point as it relates to the actual variable. And in this case, we can see that the problem for this space was the temperature, that it's running warmer than it's supposed to, and we're running in and out. In addition, we're measuring the door usage, how many times they cross critical zones. And a really unique feature is, again, the ability to change this settings for an operating room based upon either the type of surgery and or the doctor. In this case, we're set up as Dr. Watson. And I'll point you to the set point of 70 here. And we're going to go, let's just say we're going to change this, but rather than the doctor, we're going to say it's heart surgery, and we're going to push apply. We can see right here that the set point changed to 65. And then you get an immediate indication showing that these set points have now changed. And then are we tracking as we're supposed to? So it's not only a means of easy control, but it's also validation. And validation, we feel like, is going to be critical in the years to come as systems become smarter and as there's more of a call for these types of spaces, not only to represent what they do, but to have that validated as well. Let's see here. We're also going to take a look as an example of what you might find. Let me see, we did the operating room. Yeah, there's another operating room. Phoenix is endeavoring to look at another means of critical analysis for operating rooms. And if you take all of the parameters that are associated in a particular operating room, it can actually be put into an algorithm which gets you a number known as an EQI number. And the EQI is essentially taking all the parameters and they're weighted to determine, is this a safe operating room or not? And this gives you an example where you might be looking at 8 ORs trying to determine their ability and their level of EQI, which is again a rating for I guess cleanliness within an operating room. And we'll look at some of the parameters that gets a little busy, but in this case you could do like we had talked before, where we're going to go through and we're going to reset the door counts, ready to begin the procedure, and we can set who's going to do the procedure, or we'll do orthopedic surgery this time and apply it, and then essentially that could be it. But in this case, we'll go ahead and jump down into the actual analysis of what's happening, and you can see that this is a representation not only of the temperature, the air change rates, humidity, total VOCs, all kinds of information from differential pressure, particles in a clean room. The lower the particles, the more cleanly of the operating room, and that's typically tied to an ISO classification. In this case, we're actually giving you what the classification is for a particular operating room, and then you can see the set points change based upon the procedure and or the doctor. And so again, we're not only setting the system for its operation using the accuracy and the repeatability of the Phoenix valves, but now we're able to validate, providing a very simple method. And as I said, this is a little bit of what's to come. As we said, you can look down here at this environmental quality improvement rating, the EQI. And the lower the number, it gives you a pretty good indication that this operating room's, from a standpoint of all these parameters weighted and taking into account, that the operating room's in a good place. Another way of looking at it that you might see down the road is the EQI floor plan, which this actually would then show you the operating rooms based upon this EQI number, and what that might look like. A pharmacy room that we've been working on as well, that we can again, very similar from a standpoint of what you might see. Floor plans can be developed very easily, where you can show red or green from a standpoint that all the parameters are good. There's a lot of new standards that are directly tied to USP 800. And in this case, we're finding ourselves, again, not only providing what we're used to providing with information for the Phoenix valves, which you can see here, but we're also providing direct integration to the fan filters, which are becoming a very pivotal part of the design that we're seeing for these spaces, not only from a standpoint of grouping and or control, but the overall accreditation is based upon these systems working and functioning. So the importance of being able to see this information, and not only that, see it from one actual location, which we're now displaying with Vision, is paramount. And not only from a standpoint of, as we said, validation, but even control, where if there was a means of wanting to turn something off, either individually, in this case we're showing where we could turn off a bank of fan filters and or turn them back on, have some sort of an analytic that we could determine that certain fans should be on. You could even have additional fans as backup so that you could service some of the fan filters with the HEPA filters and have the other ones running so you wouldn't lose any downtime. Accreditation, as we said, is key for these pharmacies. And so we have a multiple array of histories and or reporting that we can do within these types of spaces to provide the analysis for just about any variable that you might need, and an easy way not only to see the information but also to provide your own reports based upon what you might be needing to determine for each of the individual spaces that you might be dealing with. In addition to these specific floor plans and or requirements, there's a number of additional reports that we can provide, from a summary of reports that gives you all kinds of individual criteria. When you run these, it looks at all the points associated with a particular area. It could be an operating room, could be a suite of operating rooms where you want to see the air change rates. It could be where you want to look at particle analysis. Again, there's really no limit. You can create your own criteria, like just show me the ones that have an ISO classification greater than 8 or greater than 7, which determines its cleanliness. And as we said, down the road, maybe with the measuring and the metrics that are put in place, we could be using EQI values as well. All of this information, you have the ability of creating your own charts and reporting that you might see with just any system. But again, this is meant to be end user capable, so you can zoom in, look at various points, create just about any type of report that you want. You have the calendar capability, so you can parse and look at this information very easily. Even if you're saving years worth of information, it's very easy to get to and view it. There's scheduling capabilities where you do a drag and drop, and so it's very easy to manipulate that as well. A range of alarm consoles where information can be emailed as the primary method, or just notification either at a PC or even on larger flat screen displays that we're finding installations more prominent for your suites and other areas that you might want to be looking at a complete floor plan where you can see the red and the green analysis that you might be interested in as well. So the whole Vision product has a lot of applications associated with it in all the critical spaces that we have found ourselves drawn into over the years, from laboratories to vivariums, and now we're finding a lot of applications as the critical requirements in some of these operating rooms and pharmacies and other healthcare facilities, as we look more at the pandemic modes that we're going to be hearing more about. So if any of this you find of value and you would like to get more information, just contact phoenixcontrols.com. I believe there's an Ask the Expert link that you can go to, or any of your Phoenix local representation should be able to get you information as well. And be looking for more of these quick application scenarios that you might find of benefit.